like to start by saying how happy I am to be at a conference that supports the expression of such unpopular ideas. I'm going to be talking on the subject of frameworks and why we want them. I should say a bit about who I am and where I come from. I work with the Fluid project, who are a group of people primarily interested in accessibility who work in Toronto. We've got a number of partner projects that we're engaged with at the moment. Some of these are working in the space of museums or academic projects. And generally, the issue of accessibility is one that is strongly underrepresented in the world of web technologies. If any developer deals with it at all, it's largely as an afterthought. The world is full of exciting new whizzing technologies that often leave people who have different requirements left behind. But the talk's got a larger focus since I'm intending to talk about larger issues about the way that we think about the code we write. Since the biggest problem is that software doesn't work the way that people want it to work. If you find an interface that you don't like, there's nothing you can do about it. Generally, you can submit a bug report and see if anybody pays any attention, but usually they won't. So there's a certain mindset amongst developers that I wanted to characterize, that developers, when they have their code and when they reflect on how to deal with a threat to their architecture, there's a stereotypical way that they'll tend to react, and this is by becoming what we call kind of code misers. They'll hide the visibility of their code from other code, or they'll hide data from other people. In particular, they'll hide it from their clients because, of course, developers think that they're the only people who should be allowed to get their hands on code. I mean, perhaps this version of Scrooge is a more cheerful one, but basically the image is all of this code is heaped up in private. And if you see any kind of architectural threat, the way to deal with it is by creating a module system that is like a bank vault. You put your code inside the bank vault and nobody can see it from the outside. So the central problem of software comes on these two axes. There's a failure of what you could call composability. So if you combine two modules that meet two different functions, A and B, the system that you create has got greater complexity than the complexity that's in the two modules. On the other hand, looking at your users, if you try to do two jobs for your users, X and Y, you'll discover that the work you have to do is greater than the sum of X and Y, and these inevitably lead to the death of your architecture eventually, due to this failure of composition in complexity and development cost. Eventually, every development will become an unscalable ball of mud. So, yes, I have to apologize for putting an equation here. I mean, since it will probably drive away half of the audience that we have. But anyway, this is a broad equation showing the economics of development. So how much does it cost to do something? So you pay the cost of your framework and your tools. And then on the right is some function derived from what you actually get done as work. What functionality do you deliver to your users? And so there's some constant scaling factor, which is, your day-to-day grind, which is the sort of thing solved by frameworks such as CoffeeScript. And then there is this exponent here, the gamma, and this is the thing which is going to kill you in the end. So if you imagine this is a quadratic function, then your cost goes with the square of the amount of stuff you deliver, and clearly what you really want is this impossible dream, this real code utopia of having your development costs simply being proportional to the amount of work you do. So can we get there? What kinds of things are going to... So, there's plenty of things in the world which reduce things which reduce typing, things which reduce verbosity. better tools, but what kinds of things will help you bring down this exponent gamma? So, here's a picture of your app. If you imagine each one of these little bobbles is a module. You want to make some kind of assertion about your application, or you want to change the behavior of some application. So if your application is composed of this freely linked graph with islands of insulation, then you've got no language to talk about alteration of behavior because you've got no global point of view. I mean, perhaps the module system is a global point of view, but if that's part of your world, then you have to admit that that's a kind of framework. But at the moment, with opaque barriers between different parts of the application, it's impossible, faced with a user who wants something changed in the application, to make assertions about the part of the architecture which he's referring to. So this is a kind of problem which we haven't really made much progress on. We code in pretty much the same way that we started coding in 1960, and these dominant approaches that we have for dealing with the problem really don't make the issues much better. So why I'm excited about JavaScript is because I think it's a great environment, unexpectedly, for solving these problems. So largely as a result of having this marvelous dialect inside the language called JSON, as well as being a great model for the state which the application manages on behalf of its users, it's also a great model for representing behavior, or what one would once call code. Things like syntax trees, things which are describing what work is to be done. But clearly there's a lot to be bridged in getting this done. So our product that we're working on, our framework, is called Fluid Infusion, and a brief rundown of the contents it has in it, many of which are pretty conventional. It's got an event system, it's got a renderer, a data binding system, and of course assistance for people who want to make applications more accessible, and widgets. These are all things that you expect to find in a normal framework. But what I want to talk about is our IOC system. So this is the inversion of control system that we've been working on. And I'm glad that other speakers on track B have already talked about these, so I don't need to describe in too much detail what they are. An inversion of control system takes out of your hands the responsibility for constructing objects and wiring them together. You can think of it as being allowed to hand a box full of jigsaw pieces to your framework and for it to just work out how to put the puzzle together without you saying, well, do one thing after the other, do this first thing, do this second thing. So we've inherited many of the concepts from the Java world, which these ideas originated in. But the crucial idea that was missing was the idea of context, and this is the idea which allows us to bridge to the world of our users. Users and their requirements are what provide context, and this context awareness has to trickle down through all parts of the application structure. And looking back at that tangled mess picture we had, clearly it's impossible for context to travel across these impermeable boundaries in our architecture. Everything in the application has to have a line of sight to the place where context arises. So contextual awareness has to be the crucial aspect which is entered into the system, and especially the transparency which the JSON model gives us is going to be the principal weapon we use to transmit context awareness throughout the application. That's the wrong way around. Right. So let me just skip ahead a bit. So this is what we call a demands block. So this is a fragment of configuration of the application. And as you can see, it's clearly simply a JSON object. We don't have funny things in here. We don't have function calls. The only potentially funny thing we have is this expression in curly brackets here, which is something that matches a context name. So what does this thing do? This thing is a rule for explaining how a particular requested operation is to be resolved in a particular context. So the first name is the name of the function which is required, and these functions exist in a global, a truly global namespace of functions. It's a moral namespace. There may or may not be any particular thing sitting in a particular global scope that does this, but this name uniquely defines the function which is required. The second name, well actually the third name really is the name of a function. So in this particular case, we want to honor the requested function by choosing the name of a concretely existing global function. Now the second name is the crucial one. The second name identifies the context. So in this slot, we're actually allowed multiple names. So you can think of this as a kind of CSS system for talking about code. Multiple context names, when matched, provide a more specific concept of the context. So a rule which matches more contexts will beat one that matches fewer contexts. So these two names interact in a kind of partnership. The demanded function name is the name of what the user wants done. The second name or multiple names define the scope of matching of this rule, and the final block is the disposition of this rule. And this disposition is again configuration, and this configuration is also addressed at this tree. So if we skip back a bit to this kind of tree, unfortunately every structure in computer science ends up looking like one of these boring structures, but this one has a particular interpretation. So this tree is a globally visible and globally resolvable data structure. And it's shown partway through the process of instantiation. At this point, marked in green, the component marked in green is the one which is currently resolving. And by process of resolving these rules, the context is drawn from the section of the tree shown in yellow. So you can see that this tree is, in some ways, a model of a standard scope system, apart from the fact that the actual nodes themselves are added to the scope as well as their children. This is just the way that scopes work in normal programming languages. So these yellow boxes form the context both for the purpose of matching the rules, and secondly, for the purpose of matching the disposition of the rule. So, for example, this contextualized expression in curly brackets undergoes what's called value resolution. So this value is resolved contextually in the tree according to what can be found in it. So what was the crucial feature which was lost when the sacred Brendan Eich constructed JavaScript from the raw materials of Lisp? There was a crucial property which Lisp has above all other languages, which JavaScript doesn't enjoy. And this property is called homoiconicity. This is the equivalence of a programming language's syntax tree with a data element of the language. This allowed Lisp programs to operate on themselves with special kinds of functions which were called macros. And macros were functions which accepted one block of code and produced a different block of code. And this is the one thing which we don't have in JavaScript. We can't transform the insides of functions. We can only transform functions by wrapping them in other functions. So we have higher order functions, but we don't have macros. So it's clear, looking at these kinds of structures, you can see that this structure being specified purely in JSON bridges the gap to this crucial property. And it's clear that to make really scalable and efficient designs, we need to be able to recover this property, because most interesting requests for new features by users will require the tree of code to be transformed. So this structure here serves many roles. I mean, it has the classic role of collecting all the widgets you've made, but it's also a map of all the state in your application as well as all the dependent structure. But it's also a computational structure like a syntax tree or like a map of nested scopes, like a call stack. So this is a multi-purpose structure which will enable a new kind of programming. So as some kind of concrete examples of the kinds of things which we're interested in achieving. So imagine these two views of an Amazon page. So these are clearly the same resource in some sense. One of them is displayed on a desktop browser, and one of them is displayed on a mobile. Now, Amazon can solve this by throwing money at it. They simply develop the page twice, and they say, okay, this is your small cut-down page, and this is your big page. And this is just dealing with one class of user, the biggest top-level division of users into ones who like small things on mobile screens and ones who like big things on desktop screens. Imagining the whole universe full of different things that people want done. You can imagine this is a very small start on the kinds of problems which we expect to deal with, but we've got no answer even to this top-level division, other than just write the thing again, and maybe you can share a couple of widgets between the two of them, but that's about it. Imagine all the kinds of special needs which users might want. I want there to be a different contrast. I've got special navigation requirements. So, in fact, people are so desperate for even this kind of transformation that we're doing work just simply to fake out the Amazon server side by sending a user agent string pretending that, say, a desktop browser is really a mobile browser, because people who, for example, want simplified content for some reason, this is the first way they've ever been able to get it, and the way they get it is by impersonating a mobile user agent. So all kinds of contexts in which you have different needs. You're wandering along and you're operating this thing one-handedly. Wouldn't it be great if it switched to a really simplified interface that could just respond to broad gestures, and perhaps when you've got some more attention, you can use the fine-grained version of the site again. Anyway, so these are the kinds of issues that we're interested in solving with this new approach to building software, labeling software that is much more like this squidgy iPhone. Users really want to be able to pull your stuff apart and make it work the way they want. Whereas if your code is sitting in your Scrooge silo, there's no way they're going to be able to get the stuff out to get the things they want to do. So I'll end with this inspirational quote from Johnny Taylor that we can't even imagine what better UIs look like, because we're a community who's full of people who are just all used to working in a particular way, and we produce interfaces which look and work a particular way, and in general they don't work the way that our users want them to work. So I'll skip over examples of markup and say, yes, we want this kind of out in the open model of transparency where things can be picked apart and bolted together again. And here are all our details. Thanks very much.